Great. So, I can hear you back there chirping. Please come back into the room because this one is really interesting, so you need to be here. So please, everyone, we have a presentation, and after that, we will take another coffee break. Yeah? Okay, so because all of our funds, we spend it on coffee and food. We didn't have any money for a publicity jingle, so I will sing for you the jingle, and after that we will talk about it. Okay? Are you ready? Okay, so, no, I'm joking. I'm terrible. I just want to mention again our sponsors. So the main one is Google, Nagaro, Endava, Kong Design Soft Vision, DNS Global Solutions, BCR Innovix, Softelligence. If you're not paying attention, I will ask you what I've said here. So please be attention. Softelligence, Cafion, Quest Global și Școala Informală de IT. Okay, so the moment I was waiting all this day, it's coming. Right now, Nishu Goel will present to us JavaScript surprises. So please, Nishu. Hey! Let me hook you in.
Is it? Yeah.
Great.
Yep. Thanks. All right. Hi, Craiova. How is it going? All right. So I am so excited to be here. I hope you are still excited and energized to learn something new. Is that the case? Yeah? Yeah? Awesome. So first of all, I'm so grateful to the team for flying us down here and for getting all of you here. I hope you've been learning something new since the morning. And that, I think, brings me to a question, because I was preparing, what I've been working on, and I was not that, interestingly listening to the talks that were going on here. So I would ask you, what have you been learning since morning? Throw some words. I know one word. I mean, I think I'm a better listener, because you're not answering. It depends. I heard that there was a talk about Vertex AI, which was pretty interesting. What else did you learn?
Cloud. Yeah, Terraform. Yeah.
Terraform.
Yeah, very interesting for me.
What else? Terraform, Vertex AI.
What have you learned? I'm going to say again, it depends. It depends on what you're looking for.
No, but what did you learn?
I don't know. It was interesting to talk with the stable diffusion and the images and stuff like that. So the fact that you can build like a story out of text and images, nice.
Okay.
I'll move on the other side. So.
Yeah. Anybody from the right side?
Flutter, about Flutter.
Flutter.
Yeah.
Okay. Awesome. I think, so we have few words of what we learned since morning. And I was sitting back there, and I was trying to collect what's going on in the talks. And I wonder if people at the back are able to kind of, connect to what's going on. Do you want to maybe move a bit ahead and try to understand better? If that helps. Completely your choice. Feel free to if you would like to, because I really have a bad eyesight, and I was not able to look at the slides and see what was going on. So. Yeah. All right, so my name is Nishu Goel. I work as an engineer at this company called ePilot GmbH. most of my work revolves around building the web, breaking the web. We do that a lot, don't we? Building the web which is performant, and basically exploring good ways to make the web in all a better place to work with. Since I talked about breaking the web, there's another question that comes to my mind. How many of you have broken things, for example, by deploying some code to production on a Friday evening, and that ruins your weekend, completely ruins your weekend? Yeah? We've done that a lot, haven't we? That brings me to another question. How many of you are JavaScript fanatics or JavaScript developers in general? Wow, OK. That's not a huge number, but I hope the number becomes huge after the talk today and you get really interested in knowing at least what JavaScript is. So my talk is titled JavaScript Surprises, and I'm not sure if these are going to be surprises to you, but this is basically about how the web is built in general and what we expect out of web in general. So I'm going to give you a backstory of what this talk is all about. Back in the year 2021, I wrote a chapter about the state of the web with HTTPArchive. Has anybody heard about Web Almanac or HTTPArchive? Yeah. Has anybody heard about Crux, Chrome User Report? OK, so this chapter was based on the Chrome User Report, which basically analyzes the millions of websites that go into, that we use on Chrome on a daily basis. And in the year 2021, the number of websites was 8 million. And all the things that we're going to talk about today are based on the statistics from those 8 million websites. So should be pretty interesting. We go further. The speed and consistency with which JavaScript has evolved has been tremendous, right? If you're a JavaScript developer, you would know that. We primarily started with using JavaScript on the client side, but here we are now using JavaScript by running servers within browsers. Can anybody tell me what I mean by saying running servers within browsers? Anyone? I'm going to give you an example, and then maybe you can, recollect the term that I'm trying to get here. So has anybody used Code Sandbox or StackBlitz? We do use those online IDEs, right? And has anybody tried to maybe not set up their whole system for running Node.js within your machines, but maybe just have the browser do it for you? We can now do that with JavaScript. StackBlitz, Code Sandbox are the IDEs that would allow you to run Node.js within your browser. And this screenshot is about that. This is from StackBlitz. We lost the screen. Yeah. And here we can see we are running Node.js within the browser. There's a URL, StackBlitz URL. And we can do that within the browser. Does anybody know how that happens? It's a recent advancement that has happened in the JavaScript world. So. All right, since there are not many JavaScript developers in the audience, I can expect that response. So it's due to web containers that we are able to do this. WebAssembly is the new thing that empowers the web a lot now, and web containers allow us to run servers within browsers. You do not need a local machine to run a Node.js project. Go into Angular or Next.js or any other project, and you can just run the whole thing within your browser as a complete solution. And that brings me to the same slide, which is about what the idea of having a browser initially was. It was about having a browser as a mini operating system, right? Being able to do everything within the browser. So by the end of this talk, let's see how closer are we to this vision, right? How closer are we to making and understanding browser as a mini operating system? So we've already seen that we can now run Node.js within browser. And now, since we're talking about JavaScript and JavaScript scaling a lot, coming from the client-side world to this whole new world, let's talk about how much JavaScript is actually loaded in the browser. So on a median mobile page, you would see that 427 kilobytes of JavaScript is loaded in a browser. And this was not initially, in the last year, it was some 30%, no, 18% down, this number. And now imagine if the usage of JavaScript grows at this scale. Imagine the CPU effort that goes behind. Imagine how the browsers would be able to up to do with with the browsers with that scale, right? And now that we know that this is the amount of JavaScript that's loaded in the browser, any guesses on how much JavaScript is actually used from what we ship? We're shipping 427 kilobytes, but how much is it actually used? We'll come to that. Before that, there's a bit of context to help us understand. Back in the year 2005, we couldn't even see script element in one of the elements that are used in the DOM. But now, in the year 2021, script is one of the most used elements, right, from the top 10 elements that are used in JavaScript, in the browser. And now, with that progress, if you look at the amount of JavaScript that's shipped to the browser but then wasted, which means it is not used, is 155 kilobytes of JavaScript. So who can tell me what is the total number of JavaScript that we were loading in the browser? We just talked about that. 427 kilobytes, right? And we are wasting 155 kilobytes, which come down to like 36.2% of JavaScript being wasted. And this is the big query that we wrote to, kind of get that percentage. And this kind of gets us the unused JavaScript from the browser. But now imagine, with that much amount of JavaScript getting wasted, are we doing the right thing to the web in general? Are we doing it right to the web world in general? Maybe not. Any idea why we are wasting that amount of JavaScript? Why we are not using so much JavaScript? And the answer is very simple. If you're a developer, you would know why, what could be the reason for so much JavaScript not being used, or there could be extra code in the browser that we're shipping. Any ideas? Yep, go ahead. Interesting, yeah, that's one of the answers that I was expecting, and is correct. We're using a lot of third-party libraries, right? And they contribute to a lot of code that might not be required, and we get all of that from the library for just using, for example, an underscore from Lodash, right? You just need underscore from Lodash, and you get the whole Lodash library. Is that justified? You need one Material UI component or icon, but you get all of Material UI, which is huge within itself. Right? So that's one reason. What is the other reason? How many of you are using JavaScript frameworks? Angular, React, Svelte, Vue. We do, right? When we're working with JavaScript now, frameworks had made it really easy for us to build websites. And if you're working with frameworks, you would know that there's a lot of boilerplate code that comes with these frameworks. Right? It's not always, maybe you don't require that much code in the background to run. Maybe you could, configure your Webpack config to maybe load, minify your bundles and maybe load less of bundles. But we don't do that, right? The frameworks have set it up all for us, and we're just building websites. So that's where the contribution towards web and, those larger bundles, which have a lot of JavaScript getting wasted, could be the reason, right? One, the third-party libraries. Second, these frameworks that we use. Do you ever go back and think, maybe this library is doing a simple job, and maybe I'll implement it by myself, instead of actually getting that library and using that? We don't, right? We are in the rush to implement a feature. We find a library that does that already on NPM and get that in our project without thinking how much cost that is adding to the web in general, to the browser in general. And since we're talking about this, we should also talk about the solution to it, right? We know that there's a lot of JavaScript in the browser. Let's talk about reducing that JavaScript. How many of you, when you're working with the performance of your applications, go to Lighthouse or any other, like PageSpeed Insights is another tool that helps you analyze your websites? Do you go to those websites to analyze what's going on? How many of you do that? That's a great practice, right? So Lighthouse is the one that was most used and have been being used. But then there's another one called PageSpeed Insights that really gives you correct statistics, right? If you are a web nerd, a web geek, you would have already figured out what web.dev is and how they help you measure your websites. So if you go to web.dev, that's a website, and put in your website there, it only gets the statistics from the first load, not like the multiple pages, only the first page of your application. But it tells you how much JavaScript is being wasted, what are the potential savings that you could do with your, for example, in my case, it tells me that the base elements bundle itself is taking, these many kilobytes of size, and what are the potential savings there. So this kind of keeps you on your toes to see where you could improve. Right? And it's not only about the problems, they also provide you with the solutions. They're telling you that these are the potential savings and this is what you could do maybe. Like it mentions that you should split your JavaScript bundles. You would use react.lazy if you're using React, right? You could do code splitting at the Webpack level if you're not using React, or if you're using any other framework or a vanilla JavaScript project in general, right? So these are some of the solutions. I was looking to provide you with some ways to improve your bundles, and one is this. This is called Webpack Bundle Analyzer. How many of you have heard about it or used it? Great. So this basically gives you a real picture of what your dependencies look like, how many different dependencies take up what amount of size. Like if I look at it, when I analyze my website, my bundle, and I get to see that React Beautiful DND is taking this much amount of space. And then I go back and think, maybe React Beautiful DND is not such an important library for my project that I allow it to take that much space and size. Then I go ahead and look at Popper, for example. Now, this is definitely coming from some third-party library, right? I don't remember using that in my application. But that really makes me think if this is the right approach to building my website, building my application. Do I really want all of these libraries to take up all the space in my, all the size of the bundle? When I'm really trying to code split my application, lazy load the different assets in my application, this may be not a good idea, right? So the second thing that you could already be cautious about the size of your dependencies is doing it at the runtime. There's this extension called import cost. Has anybody heard about it? No? OK. So this basically tells you while you're developing applications about how much size a dependency is taking. For example, I wanted to do some internationalization in my project, and I imported use translation from an internationalization library. And suddenly, I get this red alert saying that, oh, this is a huge size of a library. And that's when you go back thinking, should I just delete it? Should I just use some other library that helps me with translations? Right? So you go on your toes right after you import some library. It's not like an extra job that you have to do about the performance of your application, but you do it right when you're developing your application. So this is a great library to help you with that. It's a VS Code extension, Visual Studio Code extension, which you could use for that. So all of these things really help you understand how you should analyze your bundles, how you should be really careful about the different libraries that you use with your applications, and also maybe choosing the framework that you're building with. That in the initial stage is not very important, because if you're a good engineer, if you really care about the, the deep aspects of, for example, Angular, React, or any other framework, you would really dive down and see how the framework works. Right? You would not just use the default settings of the Webpack config, for example, or the default settings of how your first page render happens. If you work with performance, have you heard about the terms LCP, FCP, FID? I have a little sticker here, which, yeah, this one, it's like a pilot thing. Whoever tells me the full forms of these three, I mean, or I don't really care about the full forms, but then the meaning of these three, FCP, LCP, and FID, they get this. I saw the first hand from you, so you can go ahead and answer this for me. Sorry, can you use the mic, please? Yeah, thanks.
For RCP, it's large content paint, if I remember. Okay, can you hear me? Okay. So
Yeah.
RCP is a large content paint.
Yes.
If I recall. FCP, I remember, is first content paint.
Yes.
And the fourth.
FID.
First interaction, I believe it is.
It's a little bit similar. You can try, or you can just tell me the meaning. Like how does it matter to the browser what FID is?
if I remember this, is the first time when the browser started to paint.
Kind of, yeah.
Yeah.
So, yeah, thank you. There you go. I have a limitation to move, so yeah, thank you. Thank you very much. So yeah, we talked about 3 terms, LCP, FCP, and FID. LCP is largest contentful paint, and what that really means is, what is the largest amount of time that it took for your first render to happen? The first render of the, the assets on your first page. How much time did it take to, render in the browser? When is the first time that the user was able to see all of the paint on the browser? FCP is the first contentful paint, which is how much time it took for the first paint of the application to happen. And FID is first input delay, right? This is similar to what you were mentioning, but it basically means when was the first delay in rendering happened. And I'll show you a chart which is kind of related to what I mean here. And this is a snapshot from how the browser works. You might have seen this if you're working with JavaScript. And you see I have this arrow somewhere until like 22 milliseconds, right? And this is the amount of time it took for my application to render, right? This is all the time that the application took to maybe load some assets that it needed, to basically render the whole page in the browser. And I'll tell you where all of this time goes. Does anybody already know why might have the browser taken this much amount of time to render the first view? Any ideas? Come on, we have been silent all day. We have to speak. I do not have any problem with wrong answers. I have given wrong answers all my life. I mean, how do you know if I'm speaking correct things right now? It might be all wrong. Yeah. So, any idea why my application took 22 milliseconds to load the first paint? Sorry? Sorry, I couldn't. Mm-hmm. Yeah, one could be that there's a lot of extra code, right? That's kind of not allowing the browser to just render the whole thing. So basically, there's a lot of scripts that we use, right? When we're working, it could be the fonts, it could be the style sheets, all of those scripts. And we saw that script is one of the most used elements now. So the browser waits for those scripts to be loaded, first of all, downloaded from wherever third party we are inviting them. And the second is to execute them in the browser. And that's when the first render happens. Anything that you see on the first page when you go to google.com or any other website, the amount of time that it takes is the time that it took to load, first of all, download the script, and then execute it, right? And how can we help that? In this case, this is when the first, before the arrow time, is when the browser was actually downloading all the scripts, it was executing all those scripts, and then finally gave you some result that you could look at and be happy about the website that you wanted to go to. So one way of doing it is async attribute. Have you used async attribute in your script elements? You might have, right? We use script element in the, it's still here? Yeah, sorry. We use script element in our whatever dependencies that we want to use. And then we also use async with that. Now, any idea why, any clear answer to why we use async? Not wait for it to finish downloading it. It's kind of close, so it's very specific because async attribute helps us to not wait for the downloading to happen. The downloading of the script happens in the background. The browser doesn't wait for that. And it simply waits for the execution time. It still waits for the execution time of the script, which is why it's not crazy fast with just using async attribute. So the browser saved the time of downloading the script, which is happening in the background, but it's still executing the script, and that's where the delay is, which is a little bit delay. And once it has also executed the script, that's when the render happens. However, if you use the defer attribute, with this it becomes very fast because the downloading time is completely saved. The browser doesn't wait for downloading. And the execution is deferred. That's what the name means. That's why it's called defer, because the execution is deferred to once the first initial page is loaded. Which is why you might have noticed that in the first view, you see all of text on the browser, but then something like CSS or fonts or like any of the style sheets that you're using come a bit after, right? This happens because in the first view, you get the content which was required, the text content, and then that's when the execution happened, right? Which was deferred because of the defer attribute. And once that execution has also happened, you see the CSS, the different styling, and all the fonts that are required. You might have also observed that on some sites, you see some other font, which is like the default font of the browser, and then when the website has loaded properly, you would only notice that now on like bad internet connections, right? If you throttle your the network to be like 3G, 2G, or something even lower than that, you would notice that change from one font to another, or one style to another, or the image is not loading, for example, right? So all of that depends on these attributes being used. Now, there's one interesting thing, which might be very interesting to the JavaScript developers, is we saw an anti-pattern, and that was that we were seeing websites using both async and defer. Now, what could be the one reason of developers using async and defer both on their script elements? A hint is that it's related to the browsers. Any idea? So it's because we used to have different browsers, right? The modern browsers would have something supported, but then the older browsers might not like support defer, for example. So the developers used to keep both of these. If the browser supports defer, it would use defer. Otherwise, it would fall back to async. But the problem with this is that, first of all, we have only modern browsers now, right? So it always falls back to async. Async always takes precedence over the defer attribute. So it doesn't really help with the execution part, which defer allows to, kind of do after the first page has rendered. So this was an anti-pattern, and this is not a good idea to do, because it doesn't really help you render your application and, the browser does not wait for execution or the downloading of the script. So to solve this, this was actually noticed in the year 2020 Web Almanac. When the chapter was being written, it was not me in the year 2020 who wrote it, but then this pattern was observed. And when we analyzed, we ran the script to see how, which all websites were doing it, or what all, different elements were contributing to this anti-pattern. And it was because, what is the first result that you see there? What is the first script that you see which uses this anti-pattern a lot? stats.wp.com, right? So that's WordPress link here that was using this anti-pattern a lot. And then when this was pointed out, WordPress actually decided to improve it. And since there were no modern browsers, they decided to just remove this anti-pattern and use either defer, if they wanted to use defer, or just async, right? And now we were expecting that after the year 2020, when we do this chapter again, when we analyze this same thing again, the number should go down, right? Because WordPress already improved it. And you see this script. This is the script that we use to basically give us a percentage of how many websites were using this anti-pattern on the first load of the page. However, in the year 2021, we saw that the number didn't go down. In fact, it increased. The last year, in the year 2020, it was 11-some% of websites who were doing this anti-pattern, which is async and defer used at the same time. But then in the year 2021, it actually went up to 35.6%. And we were really confused why this is happening, because this was solved the last year. This was solved in the year 2020. Turned out, the way we calculated the percentage this time was a bit different. Now, we were not doing it at the first load. We were doing it by scraping these websites after the whole load of the page had happened. So we were doing it, and we realized that a lot of websites were dynamically injecting these attributes. Do you see this dynamic injection where async is also set to true and defer is also set to true? So this contributed to that hike in the, in the percentage, which was like 35-point-some%. And if you know what Pivot is, this is more like an analytic tool. And we noticed that most of the analytics websites were doing this, dynamic injection of scripts with both async and defer set to true. So the expectation now is that in the year 2022, the Web Almanac for this year is going to come in few days, or yeah, it's going to come in few days. The expectation is that the number should go down if they have already improved it. So I think all of us will be waiting for that and seeing what happens. But the idea is async and defer, using defer over async definitely helps you if you want to, not let your browser wait for the stuff to load until, your website has loaded. And if there are important elements like without which you do not want the first render to happen, you don't want the user to wait for a different font to appear after some time, you wouldn't want to use defer in this case, right? You would want that it's okay that the browser takes 12 milliseconds or something, but I want to give the first-hand experience as the best thing to my user. So that's about this. And now that we're talking about JavaScript, this is a bit of context switch here, but since we're talking about JavaScript, let's also talk about frameworks, right? And this is not going to be an Angular versus React thing, so don't expect that. But this is more on a general level. What is something different that you see here? Is there a comparison in Angular and React? Maybe not. But what is like, different here? It is that jQuery is still ruling the world, right? And I met somebody this morning who is a jQuery developer, and we were talking about how jQuery is still, kind of ruling the world. And now imagine discussing Angular versus React or React versus Svelte. Do you feel you do justice to yourself by discussing that? Maybe not, right? jQuery is still used by 84% of the total websites. And when I say total websites, it's basically the 8 million websites that we analyzed as a part of the Chrome user report. But 84% of websites still use jQuery. There's also React. There's also Angular. But the majority of the work is done by jQuery. And now you would ask me or ask yourself, why is that the case? I mean, every JavaScript developer that I see is using a framework. Somebody is using Vue, somebody is using React, and React is being used a lot, right? So why is this still the case? Can anybody answer this for me? What do you think? It's also related to third-party libraries. It's also related to a lot of other frameworks being used. Any idea? WordPress. Yes. So these are the two answers that I have for this situation. One is that we use a lot of third-party libraries, don't we? Do you always check if the third-party libraries are somehow using jQuery? Most of the time they are, right? And if you're using any older libraries, they are based on jQuery, and that adds to this indirect adoption of jQuery in your applications. That's why this percentage. What is the other reason? WordPress, you said. So WordPress is the only CMS which is like 1/3 of the total websites that we analyzed. And WordPress uses jQuery in the background. So that's another reason for for this crazy percentage of jQuery being used. So these are the two reasons which we mentioned, WordPress. And when I say 1/3 of total websites, you would see that that's actually fact-based, and that's actually from statistics that we noticed that of all of the CMSs that we use, WordPress is 1/3 of the websites, right? And the second is indirect adoption due to some third-party libraries that we use. And this is what I was talking about. When it was another chapter in the HTTP archive. This is the CMS chapter. And we noticed that 1/3, all of the blue is WordPress, right? So this is why WordPress always contributes to jQuery adoption or all of the other reasons that we saw. Yep. Now, this is not really important in the slide, but then if you really want to justify your understanding and see why jQuery is due to WordPress, you would notice that version change. In the year 2020, WordPress actually announced the new version. They started adopting the 3.5.1 version of jQuery, and that's when 3.5.1 version of jQuery became the most used one. And before that, the only version that was the most used was the one that WordPress was using before adopting this new version. So that kind of justifies our fact, the slide from before, that WordPress is actually contributing to a lot of jQuery usage. And in here, I'm not talking about this framework in general, but then to end the whole discussion for today, I would really ask you, as a JavaScript developer or as a web developer, do you really want to do all of this when you're developing a website? When you're building a website, do you really want to care about lazy loading? Do you really want to care about using async or defer? Or do you just want to build cool websites? We just want to build cool websites, right? We shouldn't have to care about choosing where to put async attribute, choosing where to use defer attribute, right? We shouldn't have to care about lazy loading our attributes or the elements, the images, the fonts, because we want to ensure that the website is fast. As a web developer, I simply want to build cool websites and serve the needs of the clients, right? Or yourself, right? So you want that the browser does it for you, and that's Quick is one of the frameworks who's already doing it. They do auto lazy loading. They handle the caching of the different assets that you use by themselves. Hydration, there's no hydration in Quick, and all of it is taken care by the framework itself. This is the basic idea of building the web, right? And in the first 2 slides, we saw that browser in itself should be a mini operating system, right? So this kind of brings us to the end of the discussion for today, and makes us think that if we're really doing the right job by having to think about all the lazy loading and the hydration and caching stuff, do you not want the browser to do it for you? If you do, I think we need to really contribute to a healthier browser and a healthier web in general. And yep, with that, I would just end my conversation. I mean, this discussion. Thank you. Yep, I already see some hands. Go ahead. Yeah.
So I'm not a JavaScript developer or a developer per se, but I am very passionate about JavaScript because my browser blocks it, most of it, like 80% or more. The one that is not blocked is the Libre JavaScript, Libre.js.
Okay.
If you can talk about it a bit, and I haven't seen it in the slides at all. So can you say a few things about the Libre?
The Libre framework.
Yep.
There's so many frameworks that I cannot even talk about it, because there's Remix. Have you heard of Remix? There's so many different frameworks, and I don't think it's a good idea to talk about one framework as such. I've never used Libre.js, so I cannot comment on that specifically. But I think all the frameworks come down to JavaScript at the end of the day, right? They compile to JavaScript, and in the browser, it's all about the vanilla JavaScript which is there. So yeah, no comments on Libre.js as such, if I understood your question correctly. Yeah, thanks.
Anyone else? Come on. No more questions? Really?
Okay. Feel free to come back to me if you want to discuss any of these things that we discussed in the presentation, or anything apart from that in general. Thank you very much, and I hope to see you around. Thank you.
Okay. Thank you. Okay, I have one.